Hi, welcome to this video on measuring pH inside microbioreactors. So we've previously had a question regarding this, and this is some sort of pico, it's called something like a picobioreactor. Inside of it there's a little Wheaton vial that's about 20 milliliters in volume. And we've previously suggested that actually you could sort of cut a slot in these kind of caps. All those caps are very generic, and you can actually essentially get a pH sensor through there and pot it. Now, I did warn that when you pot stuff, you generally use kind of epoxy, so you've got to be a little bit careful because the fumes can kind of get out and coat, or rather can off gas and coat sensors, etc. So that is an engineering challenge. Now, the inquiry is coming from a research institution, so taking on scientific and engineering challenges is really the kind of raison d'etre of such institutions. They've got some follow-on questions, which I'll go through now. Can you use your sensor while continuously submerged in a culture broth? I suspect so, but I'll comment upon it. Can the pH sensor measure small changes in the culture? The pH sensor is not the limiting factor here. It's actually a series of electronics, and I'll probably do a back calculate. I'll come to a calculation and say as long as you can resolve 7.6 millivolts, then you can probably achieve what you want to achieve. Can you sterilize the sensor with ethanol after use? I'm going to give some advice that I think it's about 5% ethanol, but this is only advice. I can only advise, but you'll see later on. Bacteria are quite small, 1.4 microns, so in theory, bacteria shouldn't really block the sensor, which is on the millimeter scale, so it's 3 orders of magnitude bigger than a bacteria. Can sensors suffer from biofouling? Now, this is an interesting one too, because there's so many, when you say bioreactor, and there's so many things that go into a bioreactor. Some cells are adherent, some cells are non-adherent. They like to be in solution. Some cells like to get onto surfaces. So it's really, basically, I'm just, that's too broad a question for anyone to really answer. And in the end, it's a scientific, let's say, investigation that one does actually have to carry out. You can't always predict the science. You have to actually try on occasions, obviously. We do have test facilities, but we only use our test facilities on large programs with private clients who are well funded, but we are capable. They don't think they can change the cap, but can we get the cables in and out of the cap? And I'll discuss that, but that's really an engineering challenge that they will have to take on, which I will try and explain here. Can your sensors be submerged inside a culture broth? The quick answer is this is an opinion. You really do have to try. We haven't tried, but I suspect that the risk is actually low. Can you measure small changes, 6.5 to 6.7 pH, for example? Here's some data from one of our pH sensors. This is pH 10, this is pH 4. That means that we've got about 325 millivolts over a delta of pH 6. That means that we get about 38 millivolts per pH, which means per 0.1 pH we got about 3.8 millivolts. Therefore, to get your resolution of 0.2, then you need to be able to resolve on your electronics 7.6 millivolts. So our electronics and our sensors are not the limiting factor there. This person wants to integrate with a Pi, so they really have to think through. There's a handover between what we can do, sensors and analog front end, and then we give out a serial signal, but it's really for them to resolve with their Raspberry Pi solution whether they can do that or not. Can you sterilize with ethanol? Not neat ethanol. At least we have never tried with neat ethanol. So there are pieces here that's the whole, that's in some ways the point of academia and research institutes is to try. If I was to give some advice, and maybe try using 5% ethanol in DI water as a sterilization technique, because I'm basically starting low risk. Of course, the more and more ethanol you put in there, the more effect it could have, is my suspicion. Because obviously most of the time we're actually using buffers, aqueous solutions, so we don't expose our sensors so much to organic. But I know that we've actually exposed to things like 5% ethanol in our time, so that I can only comment on what we know. If an object is 1.4 micrometers, then I can't really, then and our sensor, and I'll have some scales up in a minute, but our sensor is approximately 1 millimeter by 4 millimeters. So we are orders of magnitude larger than the individual bacteria, but of course I understand it's really the population of bacteria. But straight answer to your question is I don't really, at least an individual bacteria is not going to make any difference to our sensor. Of course, this is the more pertinent question. Will we biofoul? Again, some cells want to adhere to surfaces. Some cells are quite happy to be in the culture. It really depends. And you can actually influence that yourself as well. I mean, it's the way you kind of culture, the cell culture will influence actually the behavior of the cells. So it really is, sometimes you'll find that cells will adhere to bioreactors and sometimes they're in suspension. So I don't know is the genuine answer on that. And again, if you want to kind of clean, then maybe 5% ethanol and DI water is a low risk way of trying it, but that's just an opinion. We do have test facilities. I'm not showing a bioreactor here, but I am actually saying that ZP, we do have test facilities. But if you're a research organization or academic institution, then by far your lowest cost route to proving out new applications is yourselves, because you've got labs, you've got people, you've got all the chemicals. Bringing it into a contract research organization, a private one like ZP, will be, it won't be economic, but we are actually capable. It's just we haven't with these pH sensor and bacteria. They say that the vial cap cannot be changed. They need to feed and remove media waste. I actually think you can still make your own cap, by the way. These caps that I'm seeing in these images, I could easily see that actually you could make a slot in that cap, and actually you could just drill new tubes into that. I wish I had a pillar drill here. Actually, I've got a hand drill, but genuinely you can do that. But that said, if you can't, then you've got this kind of I'm going to give you the dimensions in a minute of our pH sensor, because, by the way, that is also on the website. You'll also probably need some sort of connector, because you're saying you can't, you have to bring cables in and out. You've got a tricky problem here, because you need to, the link here will be also a button as well that you can actually go there, but there's a connector here. You have to take that sensor and put it in that connector, and you have to pot it. And potting, I've warned earlier on, is where you kind of, you seal everything up so there will be no ingression of liquid. So you really have to pot well. So there is an engineering challenge for you to overcome there. So we got sensors, we got connectors. The sensor would go in this end. These are kind of just pins that can be outside of that reactor, and you can sort of solder onto. So there's your cell, which your bioreactor, which is 20 milliliters. These are our dimensions. If our dimensions are too big, then I'm genuinely sorry, but those are our dimensions. You should be able to find that data sheet here. Here's the connector. I can see you may have to put that sensor into that connector and pot it. And I can't really advise you on potting. Potting is, the mixing of a 2-pot epoxy and letting it cure, but you've got to be very careful with it, because epoxies can off gas and they can end up putting a kind of coating of epoxy onto sensor surfaces that you didn't otherwise intend. So you do have to overcome that engineering challenge. Now these people want to possibly use this pH sensor in conjunction with a Raspberry Pi, so they'll probably need this circuit in between them and their Raspberry Pi. But you do have to kind of, there's a data sheet here, and that's the best I can give you because that's in the public domain. You have to think about, we want to make electrical connection here, but the sensor is actually going to be in here. So you really have to think through that engineering challenge. But I mean, that's part of the fun of doing this kind of research, is to fix those kind of questions. If you do have any questions of ZP, please don't hesitate to contact us. And thank you very much. Take care. Bye-bye.